So in our last section, we learned how to take an absolute value function and transform it using our transformation properties. But now let's find the zeros. Zeros are another name for x-intercepts of a function. And x-intercepts are where our graph touches or crosses the x-axis. And let's realize that when something touches or crosses the x-axis, its y value is 0. So all we need to do to find the zeros of an absolute value function is set the f of x to 0. So let's do that. Let's set 0 on that left-hand side equals the absolute value, 2x minus 4 plus 8. And then let's recall from our absolute values that we had before, and actually I'm going to change this up, otherwise it'll have no solution, so don't want that to happen. All right, so we'll change it to that. All right, so remember before when we were solving absolute value equations that we have to have the absolute value by itself on one side before we can rewrite the equation into two separate equations to solve. So this is not yet by itself because there is this minus 8 that's not in the absolute value. So let's add 8 to both sides, both the side with 0 and this right side. So on the side with 0, I now have an 8, and on the right side, I now have just the absolute value portion. So now that I have the absolute value by itself, let's recall how we solved these equations. Our first equation, we just dropped the absolute value. And our second equation, now before it was the right side that we made negative, but since this is sort of reversed, we've got our absolute value on the right, we'll make our left side negative. So we make the constant negative. And we solve these two equations to find our x-intercepts. So let's solve the first one. Let's add 4 to both sides. And while I'm at it, I'll just do it to the second one because we're going to do exactly the same thing. So we get, let me move this down, 12 equals 2x. And I'll continue with this one over here. Negative 8 and 4, though, is going to be negative 4 equals 2x. And then let's divide out the 2 that's in front of our x. And we will get 6 for this first one. And we'll get negative 2 for this second one. And those are our two x-intercepts. Now let's realize that x-intercepts can be written as points. This is 6, 0. The y value is always 0 for an x-intercept. And negative 2, 0. So if you see this word zeros in the homework, it means x-intercepts. It's exactly the same thing and the same process that we just did. All right, now let's say, on the other hand, that we want to find the y-intercept of the function that we just had. I'm going to copy and paste the function so I don't have to keep going back up. So let's just copy that and bring it down here. So we'll find the y-intercept for this function. Now the y-intercept is an easier calculation because let's realize, of course, the y-intercept is where our graph crosses the y-axis or touches the y-axis, and on the y-axis the x value is 0. So all we're going to do is put a 0 in for x. So we'll have the absolute value of 2 times 0 minus 4 minus 8, and then we just need to work this out. So really, inside of the absolute value, the 2 times 0 goes away, so I'll have an absolute value of negative 4 minus 8. Oops. And let's realize the absolute value always makes things positive, so that's 4 minus 8, or negative 4 as an answer. And we can write this as a point as well, 0 for x, negative 4 for y. And of course, if it's a function, there's only one y-intercept. There can be multiple x-intercepts, but there'll only be one y-intercept.